I'm going to blow through this because I've recorded it 3 times, and OBS has just wrecked my shite. What I'm going to show you how to do today quickly is how to get the enemy to shoot at you and how to get the enemy to run for cover. So I'm just going to have a couple of... I'm just going to have a video run in the background while I say this crap, and then I'm just going to blow through everything that I did. Okay. Okay, so the first thing we did here's the level. It's super simple. I just created a couple of mesh objects and put them in the scene here, and then I attached them all to a navigation region 3D, and then had them bake. That way they had their the navigation mesh baked in, so the enemy can go to it. Here are all the cover points. All the cover points is just a grid map. I created these little cubes in another scene, and then made them into a mesh library. I'll just go right here. I don't garbage out here, discover spot. So this is all it is. It's just a cube. And I just went down to export as mesh library and then saved it and then added it to the grid map here. And then that's going to be for all of the cover points. Then I just shrank them, which you can do right down here, and then gave it a material so it's transparent, but you don't even need it. You can just hide them so the player doesn't see them. Okay. Now that's done, let's go into the player first, because that will be the easiest thing to explain. Alright, so most of this is from the player first-person controller tutorial that I did. I'm just going to leave a link up there, so if you need it, there you go. That's how you build it. So the only thing that I changed is here in the cam pivot, I just added a node 3D bullet position node, and then I added a marker 3D for the bullet position. So when the player is firing, this is where they're going to be shooting from. And then this node is just so it inherits the rotation of the camera pivot. That way, whatever direction the player is looking at and they shoot or they hit the fire button, the bullet will go in that direction. Okay, so now, super simple. Let's go into the script here. So first thing I did was I created a onReadyGet variable called getBullets. It's just going to load in that scene of the bullet. And then after that, it's going to find the position that I just talked about. That way the bullet has a position. Now this bullet is actually super easy to make. So I'll explain that in just a second on how to do that, but let's just go right down here since we're already talking about the player. After that, I just created a input for the fire function or fire bullets function, and all it's going to do is it's going to create a new variable called get bullets, or excuse me, called new bullets, and then it's going to get bullets, and then it's going to instantiate it. All it's going to do is make a copy of that scene, and then we're just going to add it to the scene by get parent.add child, and then the child that we want to add is that new bullet. Then after that, we want to do new bullet. Its global position. The global position is where it's at in the scene, and then we just want it to be equal to the position of that bullet position. That way, that's where it's going to be fired. Or it's going to spawn at. And then after that, we're just going to find out what its rotation is. It's going to be that of the camera pivot. That way it follows whatever direction the player is currently facing. And I think that is all for that, right? Yeah. Like I said, the rest of this crap is in the first-person controller. So I'm not going to spend any more time on that. That is done. All right, now the bullet. The bullet, super simple. It's just an area 3D. I gave it a signal and a script. The signal is just right here. For anytime it enters a body, it's just going to queue free and delete it from the scene. It has a collision shape on it. It has a timer, so just in case it doesn't hit anything, after 3 seconds, it just disappears anyway. And then the mesh is just so that we can see where the bullet's at. So now if we go into the script here, you can see here, it extends an area 3D. I give it a speed variable, which is how fast it's going to go. The variable velocity is going to be vector3, 0. Area 3Ds aren't a physics object, so we had to create our own velocity variable here that we can manipulate. Then after that, whenever the bullet is instantiating on the scene, we want to be moving. So all I did was I took its velocity.z, which is its vector3, So Z is going to be -1. This is just to make sure that whatever direction we're facing is going to go in the opposite direction, and then we need to make sure it moves. So translate is a function that's built in of Area 3D, and that's just to get to move. So it's going to take its velocity, it's going to normalize it. That way, if it's ever at an angle, it doesn't go any faster than if it was going forward or backwards or left or right. And then we're going to multiply it by its speed, so it has it has a speed variable. Then, like I said before, or as I explained before, it has a timer here. Timer is activated automatically. It doesn't look like it's connected for some reason, so I'm just going to just disconnect this and reconnect it. Not exactly sure what happened there. There we go. Now it has the functions and stuff on it. But yeah, it just queues it free after a few seconds. That way it's not stored into the scene data and bogging down things. And then here, obviously, like I said before, if it ever collides with a body, it queues free. But if it ever collides with a body that is in a group of enemy, then it's going to find a function called damage. And I'll explain that when I explain the enemy. Okay, next up, the cover points. Oh wait, I already explained that. Never mind. Let's go with, I already explained the player. Okay. I guess we're just going to have to take it from the top. Okay. So, like I said before, this enemy was directly yanked from my patrolling enemy tutorial. So if you don't know how to make all this good jazzy jazz stuff, don't worry. There's a link right there. You can look at that video, and then you can come back here and follow along. But I removed a lot of the code from that just to make it easier and more streamlined. Okay, so let's go into its actual build here. So the first thing that I did, or the only differences that I have here, is this right here, the bullet position, very similar to that of the player, and the marker 3D. So this is just so where the enemy's bullet's going to appear at. I have here a check cover height. I didn't get a chance to use this, but it was just to check to see if the enemy was behind either a wall that was tall. Yeah, a wall, an actual wall, or if it was hiding behind like a fence or something. So if it collided with something, it knew it was hiding behind a wall, and if it didn't collide with anything, it knew that it was behind like a fence or a barrier that was like waist high. But again, I never got to use it. And then I got a timer here that's just going to shoot at the player. This wasn't used for the earlier example, but whatever. I'll show you before I end this video what that's going to be used for. All right, so now let's go into the code. Then, just like the player, it's going to have a load bullets, which is going to load in that scene. It's going to have the bullet position, which is where it's going to be fired from. And then down here, I have a variable called cover points. This is going to store all the points of the grid that we have here. So all these little points down here is going to be stored right inside this particular list. Then I have another list called coverpoints.order. This is going to be storing the distance of the player from all the cover points. And then what's going to happen is whichever is furthest from the player, that's the cover the enemy is going to go for. And then over here we have combined points. This is going to be a way to organize these two lists. The way I want this to be set up is I want the closest cover points to be at the beginning and the farthest cover points to be at the end. That way we can always just grab the furthest cover point that we have and give it to the enemy. Then after that, we have a variable next cover point. Again, this was explained in the patrolling enemy. Where is it at? Here it is. All it's going to do is get the position that we want the enemy to go into using its nav agent. Using its nav agent node. Then after that, I have a couple of states here. I created an enum called states, and then I gave it active, shoot, player, being hit, and then look for cover. I use an enum because it's just going to take all of the variables in here and turn them into numbers. Computers are much better at calculating numbers than they are at strings, so this is just a optimization choice here. And then after that, I need a way to call all of those states, so I just created a list and then put all of those states within inside of this list. That way we can call it later. And then as you can see here, we can find out what its current state is, equal to all states, and then one of the states that I have, which is active, just saying that it's currently active in the scene. Okay, so this right here was also used for testing. I'll explain what this is for later, but don't worry about it. Okay. Next up, the ready function. So the ready function, all we want to do is just add this to the enemy. Oh, excuse me. We just want to add this enemy to a group called enemy. We are going to use this in the level script here, as you can see here. It's just going to call all the enemies, or excuse me, it's going to call a group of enemies, and it's going to get all of those entities later, and it's going to pass in all of those coordinates. So that's why we have it added to the enemy. That way it can call this enemy later. In fact, since I'm already at the level here, I might as well just explain this. So when the level is first instantiated or activated into the scene, the first thing I want to do is to get all the cover points, which is going to be this grid map right here. It's going to grab all those cover points, and then after that, it's going to call all of the enemies that are, or all of the entities that are in the group of enemy. This is just going to be a giant-ass list. And then we're going to do a for loop. That way we can look through that list, and then we have a variable called enemy entity in the calling all enemies list that we have here. And then after that, the enemy entity is going to have a function within it called receive cover points, and then we're just going to pass those cover points in. This is just to make sure that the enemies all have access to all of the cover points within the level. That's all this is doing. Okay, we'll explain this later. I think we'll do the physics first. You can actually see right here within that level that I was talking about earlier. So you receive cover points, and then it's passing that. You can see right here, receive cover points, all cover points. So this right here is actually the grid map. And then we're going to go through that. But I'll explain that in a little bit. Damaged. There you can actually see when I was talking about the bullet. Do I still have the bullet up? Yes, I do. You can see here, it says body damaged. And right here, damaged. And all it's doing is just changing the enemy state from active to being hit. And then we got run for cover. Is that a good? Okay, yes. Okay, so let's start up from the top here. So we're going to go to the physics process here. Don't worry about this bull crap. This is just for testing. The first thing I did was had the enemy run for cover. So whenever its state changes from active to being hit, it's just going to go through all of this code here, and all it's doing is it's just finding the next position, and it's just sending it to that position. Again, all this crap was explained in the patrolling enemies, so again, we're just going to blaze right on through it. And then after that, if the current if the current state is ever equal to active, we just want the enemy to stop. So we're just going to have its velocity equal to 0, and then after that, we're going to have it look at the player's position, which this is a global variable, by the way. Again, I explained that in another video. Not going to go over that. All right, next up, get cover. Get cover. Where are you at? Get cover. Control F. All right, here we go. All right, so next up, we're going to go call cover, or it's going to get cover. Within this function here, we have another one called calculate cover. Here, all we're going to do is go 4x in the cover points. So these cover points are going to be filled up, or this list is going to be filled up at the beginning because of the level. Remember what I said when we were passing in the cover points? So this is going to be covered up first. Excuse me. This is going to be filled up first. Then it's going to have a size. We just want to get every single element that's in there. And then from there, what we're going to do is we're going to get the distance, or we're going to create a variable called getDistance, and that distance is going to be the player's current position and the distance it is from the current, or it's going to be the distance from the cover point. So it's going to look through each of this list here, find out what the cover point's distance is, and then it's going to calculate it from the player. And then what we're going to do is we're going to find out what that distance is, and then we're going to put it in that list of cover points order. Okay, that's done. And then after that, okay. Yeah, so I'm going to have to explain something first. So as I explained earlier, I want to use those two lists that I have up here to dictate the order of when those cover points should be in the list. That way we can grab the furthest. In Python, I know there's a way called zip and sort that allows you to do this, but I didn't find any documentation for Godot to do it. So all I did was I just asked ChatGPT to just give me the equivalent of that, and this is essentially the code that it spat out. So as you can see here in the testing here, I have the first list, which is going to dictate the order, and then I have the second list, which is I'm going to draw from, and I need them to be in a particular order. So if you see here, position 1 is equal to 10, position 2 is equal to 5, position 3 is equal to 33, and position 4 is equal to 9. So if I were to use this particular sort function here, what it should do is it should take this array 2, and it should organize them dependent on the variable that's up here. So, for example, position 2 should be first because it's 5. Position 4 should be next after that because it's 9. Excuse me. Position 1 should be after that, should be the third one. And then finally, position 3 should be the last one because it's in 33, which is the biggest number within that list. So I just used that, tested it out, and it worked beautifully. So I just rewrote that for us down here. Give me 1 second. Okay, so after we're done with doing that, what we're going to do is we're going to create a for loop so we can access the amount of points that we have, and then we're just going to create a dictionary within a list, and we're going to use that to order our positions we're going to order all of our cover positions based off of that. So here we have combined points. So that is the list that's up here. Combined points, yes. And then we're just going to append that dictionary. So we're going to have the order, which is going to be the cover points order. And then it's going to find each and every single one of those orders in there, which should be a float. And then after that, we're also going to have all the cover points, which is the cover points that we got from the grid map. And again, it's going to put them in, it's going to grab them and put them in the order. Now, this is because this is a dictionary, they're going to be set to keys. That way we can call them later. Then after that, we are going to have ourselves, we're going to have to have a custom sort function here within the combined points. This is just going to sort them out for us, or it's going to sort out the keys for us in the order that we want them. So right here, sort position by distance is a function that I have built. And all this is going to do is going to take two parameters, and those parameters are going to be A and B. And all it's going to do is within the list that we are sending it, which is this one right here, we want to look for the order. And if A is less than B, it's going to give us that variable, and it's going to throw it into the list. If it's greater than B, it's just going to skip it until it's lower. And then after that, I don't know why this is, but we need to sort the list out twice. You should only really have to sort it out once, but for whatever reason, it needs to be done twice. It was giving some weird results when I only sorted it once. Like the enemy would just like stop in the middle of the level for whatever reason. But anyway, this is just to make sure that the closest variable to the player is at the beginning of the list, and the farthest point from the player is at the end. And then after that, we're going to create a brand new variable called farthest point, and then we're going to equal it to the combined points dot size minus 1. The reason for this is lists start at the variable of 0, but the size is going to start at 1. So all we want to do is just make sure that it is coherent. That is it. Then after that, we're going to pass that. We're going to pass the farthest position to the next cover point. That way, the enemy can head there. So we're going to go to combine points, find out what the farthest position is, and then we're going to find out what that cover point is. And then after that, that should give you a vector 3 of the furthest point within the grid map, or the cover points. And after that, we're just going to clear them. That way, we're not storing data that we don't need. So it just refreshes the list. And I think that is all. So if you do this correctly, you should be able to have your enemy go to any position within your level. Now, this isn't perfect. He will always go for the farthest cover, even if it's on the other side of the map. So you can limit the distance if you need to by simply doing something like, if global position dot distance to, and you can say something like, I don't know, whatever cover point is greater than, I don't know, 15, then, go to next point, or too far away, something like that. So that way you can keep it reasonable. That way, like I said, he's not going across the stage here. And then let's get to the what's it called? Have him shoot. So within the navigation agent target reach, if it ever reaches its target, I just started a timer for the enemy here. So whenever he reaches it, he's just going to start shooting. This says example, but the example just calls the fire weapon. That's all that's doing. So if I actually play this now, it's going to be a bit difficult because I only have one hand at the moment. I have to hold this microphone because there's a problem with it. But if I shoot him, he'll go to his position or whatever. And as you'll see here, he should start shooting me or shooting at me the second he finds a position. Okay, there we go. He should now be near a position. I'm just going to go over here. And he should be shooting me right now. Yeah, you can kind of see it right there. A little flash. It's just hitting the, there we go. It's just hitting the wall. But yeah, so you can, like I said, do whatever you want with this. Come on, hit him. There we go. All this stuff is pretty rudimentary, so you're going to have to, you know, go in there and program it to be more fine-tuned. All right, I think that's everything. I don't think I missed anything. Hopefully this recording actually came out good because the other two came out horrendously. And I'm tired of recording it. So, with that being said, my children, if you have any questions, feel free to ask me in the comment section. I'll try to help you out. If not, all this code will be in my GitHub. So feel free to take the code and do whatever the hell you want with it, or study it, or whatever. I don't care. All right, with that being said, my children, until next time, farewell.